Now let's try to put this all together and apply it to a specific word problem. One day while watching a movie, there was a steamboat moving along a river. I thought that this would be a perfect problem for us to work on. As the paddle wheel turned, a point on the paddle blade moved so that its distance d in feet from the water surface was a sinusoidal function of time t in seconds. I took out my stopwatch to time the movement of the point. At 5 seconds, the point was at its highest, 15 feet above the surface of the water. The wheel's diameter was 17 feet. It took 12 seconds to make one revolution. Sketch the graph of this sinusoid. So, we have this problem here, and what we're going to do is write a particular equation for it. Now, I specifically told you sketch the graph of it. It's important to do that to help us to get this information. And then what we're going to do is, after we have the equation, we're going to find where's the point at time 22 seconds. So I'm going to look, set up an XY axis, and it says, what information do I know? Let's just start labeling what I know. At 5 seconds, the point was at its highest, 15. So I'm just going to mark some point. Here's 5, and up here is 15. And then it says the wheel's diameter was 17 feet. That's going to be important, and it took 12 seconds to make one revolution. So it's going to come down, and it goes back up, and after 12 seconds, so we'll put us at 17. Now, how are we going to? Am I going to draw this sketch? How far down am I going to go? Am I going to hit the axis here, or am I going to go below it? Well, since the diameter is 17 feet and it's only 15 feet there, it's going to have to come below. Now, it's not a perfect picture, nor does it need to be, but it'll give us all the information we need. So now, at this point, we can ignore the question for a little bit, and we'll just start finding the equation based on this graph. So what does this tell us? We need to go through that same stuff. A, our amplitude, assuming we're going to be starting with a positive A value, will be our max minus the min. Forgot to label this negative too. So 15 minus negative 2 divided by 2. So that's going to be 17 over 2, which is 8.5. Does that make sense? Well, I hope so. Since the diameter is 17, the middle to the top is going to be half of that, 8.5. What about D? D is our midline, our middle between the max and the min. So average them, and we get 13 over 2, or 6.5. And so this is going to be something along those lines. B, well, we know the period is 12 seconds, so B period's 2 pi. B is pi divided by 6. Because we're dividing both sides by 12. And now we need to determine, is this going to be a sine or a cosine? If it says sinusoid, it's saying either of them, because you can have a phase shift on there. You can shift right or left. That's what a phase shift is. So which one would you choose to do? I would choose to, since we know this is a max right there, let's use cosine. So for cosine, the C value is 5. And that allows us to write our equation. Now, we want to do it in terms of distance. We know D is our variable, so it's going to be D of t equals 8.5 cosine of pi over 6 times the quantity t minus 5, and then plus 6.5. And that's part A. All of this actually works for that. But that's our equation. Now B asks us to find D of 22. So take out your calculator and type that in. And when you do so, you get negative 0.8612. So what does this mean? This says we need to explain the answer in terms of the point on the paddle. We're going to write a sentence for this. This is the point was where? The point was 0.86 feet below the surface of the water. That's what that negative is telling us, because remember, D is defined as feet from the water surface. And that's pretty much it. So whenever you're dealing with these types of word problems, sketch your graph and then use the graph to write your equations. Be careful about making any assumptions that are not told to you in the problem.